Here we have an expanded sum, and we just want to take this expanded expression and write it in summation notation, which involves our Greek letter sigma. So they're telling us to use 1 as the lower limit and I for the index. That means on the bottom of our sigma here we're going to have I equals 1. So the couple of things we need to figure out is our upper limit of summation. So what's the last thing we want to plug in for I to generate this expression? And also we need to find a formula for the pattern of these numbers in our sum. And again, since we're being told to start with I equals 1, I need to come up with some kind of pattern or formula involving I, such that when I plug a 1 in for I get 1. And when I plug a 2 in for I get 1/2. When we plug a 3 in for I, we want to get 1/4. When we plug a 4 in for I, we want to get 1/8, and so on. Okay, so let's start to look at these numbers here in our sum and try to identify some type of pattern. Well, that 1 that's in the front I could certainly view as 1 over 1. And so if I look at it that way, they're all fractions and they all have a numerator of 1. And I can see that even in my last term. All the numerators of the fractions are 1. So my formula is going to have a 1 on top over something involving an I. So let's just go ahead and look at our numbers on the bottom. They go from 1 to 2 to 4 to 8 and so on. And so that pattern there is that they're doubling or being multiplied by 2. Now I need to try to express that in such a way that it is written in terms of I, and so that when I plug a 1 in for I, it gives me a 1. Plug a 2 in for I, it gives me a 2. Plug a 3 in for I, I get a 4, and a 4 in for I, and I get an 8. And so one way that we can do that is to take it as a power of 2 and say it's 2 to the I minus 1 power. That way when I plug a 1 in for I get 1 minus 1 is 0, and 2 to the 0 power is 1. When I plug a 2 in for I get 2 minus 1 is 1, and 2 to the first power is 2. When I plug a 3 in for I, 3 minus 1 is 2, and 2 squared is 4. And when I plug a 4 in for I get 4 minus 1 is 3, and 2 to the third is 8. So now looking at our formula, we want to stop when we get this expression here of 1 over 2 to the n minus 1. And I would get that if I plugged an n in for I. And so our upper limit of summation is n. So when we plug in n in place of I, we get 1 over 2 to the n minus 1. And so that is how we would write that expanded sum using summation notation.